How do we find the inverse of matrix A here? It's a 3 by 3 matrix this time. The formula for A inverse that we saw in the previous lesson is valid for all square matrices. It's equal to 1 over the determinant of A multiplied by the adjoint of A. No elementary operations needed. The condition states that the determinant of A must not be equal to 0. That's because the denominator cannot be equal to 0. If the determinant of A is 0, then we can say that the inverse of matrix A does not exist. So that's the first thing we should do. We find the determinant of A. We can have the first row as the reference. Because we've already solved innumerable determinant problems, let's go through this quickly. The element 2 will be multiplied with this determinant to get this. 2 multiplied with 1 times 0 minus 2 times 1. The next element is minus 1. We get this. Minus because we are multiplying this product with minus 1 raised to 1 plus 2. The last element for the first row is 0. Because it's 0, it doesn't matter what it's multiplied with. The product will always be 0. This will be the value of the determinant. This part in the brackets will equal 0 minus 2, which equals minus 2. 2 times minus 2 will equal minus 4. What about the second product? Inside the brackets, we have 0 minus 2, which equals minus 2. 1 times minus 2 is minus 2, and this product is 0. Minus 4 minus 2 will equal minus 6. We have the determinant now. It's minus 6. As it's not equal to 0, we can say that it's non-singular. The inverse of this matrix exists. So we can move on to finding the adjoint of A now. To find the adjoint, we first find the matrix of cofactors of each of the elements and then find the transpose of that matrix. So let's find the cofactors of each of the elements now. The first element is 2. Its cofactor will equal minus 1 raised to 1 plus 1 times its minor. Its minor is the determinant of what's left after excluding its row and column. So the cofactor will equal 1 multiplied by 0 minus 2, minus 2. The cofactor of this 2 is minus 2. Now we come to the cofactor of minus 1. It will equal minus 1 raised to 1 plus 2 times 0 minus 2 times 1. Minus 1 times minus 2 is 2. Similarly, we get the cofactor of 0 as minus 1. Now please pause the video, take your time and solve for the remaining 6 cofactors. These are the 6 remaining cofactors. This transpose will give us the adjoint of matrix A. To find the transpose, we interchange the rows and the columns. The first row will become the first column. Minus 2, 2, minus 1. The second row will be the second column. 0, 0, minus 3. And lastly, the third row will become the third column. Minus 2, minus 4, 2. Now we have the adjoint as well. And because we have both, we can find A inverse now. Let's write it here. 1 over determinant of A will be 1 over minus 6. We multiply this with the adjoint of A. What will this be equal to? This is the adjoint. To get this, we multiply this scalar with each element of the adjoint. 1 over minus 6 times minus 2 will equal 1 over 3. 1 over minus 6 times 0 will equal 0. 1 over minus 6 times minus 2 will equal 1 over 3 again. And like always, I want you to find the remaining 6 elements. Remember, we need to multiply each of the elements with this scalar. These are the 6 elements you should have got. This is A inverse. We found it using this formula. So this was pretty long, but still faster than using an elementary operation. Remember the formula. A inverse is equal to 1 over the determinant of A times the adjoint of A.